In this video, we'll conclude our discussion of input and output, reading and writing files. And we'll conclude by talking about a very important file format that is unique to Python, called the Pickle file. So a Pickle file is an example of what's called serialization. The idea of serialization is that often in a programming language, we'll be working with complex objects that are stored in memory. But we may need to transmit these objects from one computer to another, or we may simply need to persist those objects to disk so that we can shut down our interpreter and then work with them again in a future interpreter session. An example of this is if we're working with a machine learning model that we've spent a long time training on some training data, we may want to serialize it to disk so that we can load it in and use it to make predictions in the future or perform additional training. Or we may want to serialize it to send it over a network to a number of different computers serving web applications where this model will be used to make predictions that users of our web app will eventually see. For example, if I ran a web store and I wanted to recommend different products to my customers, I might, in order to deal with traffic to my website, I might have a number of different web servers that serve my application. And I would need to replicate that model on each server to make predictions of what I should recommend to my customers. So, we've seen with JSON and CSVs that we can represent certain types of data quite well on disk in a text format. But what about something like a machine learning model, something that's quite complex and doesn't necessarily have a simple representation in text? Or something even that we define ourselves that we have no idea how to represent in text. Python, along with other programming languages, provides a solution in the form of serialization. Serialization is a protocol for representing bits in memory as bits on disk. So it's a map that builds a representation on disk for an object in memory. For example, we could create this sort of complicated object of nested lists and strings and tuples. And if we tried to write this as plain text, it would fail. Write argument must be a string, not a list. And you might say, well, we could represent this as JSON. Let's try that. And that works, but we'll find that if we load this back in, certain things have changed. We'll call this Pickle JSON. For example, our tuple containing 1, 2, 3 got changed into a list. So how can we avoid things like tuples being changed into a list by JSON? Furthermore, JSON has its limitations. It won't be able to represent the arbitrary Python objects in on file. So for example, if I define some dummy class that does utterly nothing, I can't represent a instance of dummy class in JSON. Object of type dummy class is not JSON serializable. But it is Pickle serializable. So Pickle is a particular serialization capable of representing arbitrary Python objects and reconstructing them from disk into memory exactly. So we can take our Pickle example, open a file for writing in binary mode, because this is not going to be plain text, and we'll pickle.dump our object into that file handle. This looks very similar to what we do with JSON, but now we're using the Pickle module. PKL is the typical file extension for Pickle files, although you're not required to use any particular file extension. And now, if we load back in that file using Pickle, we find that we exactly reconstruct the example as before. So I actually have that down here already. Notice that isn't true for the Pickle JSON, because that tuple was changed into a list. So these two things are not equal, but the reloaded object from pickle.load is the same. Pandas also has a toPickle and readPickle method, and as do a number of other libraries, such as scikit-learn, which we won't talk about in this course, but is a very popular machine learning library. So many libraries which introduce complex Python objects include methods for easy serialization of those objects into Pickle files. Just to drive the point home, I could also pickle my dummy class. So here is a reconstruction of a dummy class object. I realize there's not like much to that class to indicate that it's what's advertised, but we do see at least that these representations are very similar. And I can even do things like pickle a class itself. So here I've pickled an object of the dummy class, but I could pickle the actual class. And there I see that I've actually reconstructed the dummy class, and I could use that to create dummy objects. So pickling is very powerful. We can pickle almost anything in Python. One example of a built-in pickling method is in NumPy. So NumPy arrays are commonly used for representing image data, occasionally used for representing tables of numbers, although pandas is usually the preferred package for representing tabular data generally. And NumPy also includes a Pickle file format for serializing arrays to disk. We'll be talking about NumPy probably next week. But for now, I'm just going to briefly demonstrate that it includes its own compressed serialization of arrays. So we could create an array in NumPy. We could save that as a text file, and it would look on disk very similar to how it looks in the interpreter. But we could also save it as a compressed binary, which has, we can see here, it's not parsed as text. We can't interpret it as text, but it's not a problem to load it back in. And if we compare these two on disk, the compressed version is somewhat smaller than the text version. 256 bytes instead of 400 bytes. So that concludes our discussion of I/O, input-output, or file formats. We used a number of things throughout this notebook, including bash commands. Those are commands beginning with an exclamation point. This is not Python. This is bash. We also used, among those bash commands, we used wget and ls and cat. I'm not going to elaborate further on these, but if you're curious about them, feel free to ask on the discussion board or at office hours. I also talked about APIs. We may or may not discuss APIs later in the course, depending on whether or not we have space in the syllabus. And I did briefly discuss this string.split method. Strings in Python, just like lists, have methods. And I highly suggest that you do something like dir string and have a look at those methods, play around with them a bit, go to the Python documentation on strings and have a look around. These methods are very useful whenever we're working with strings, so it's good to know that they exist. There will be one more lecture for this week, sort of a bonus lecture, in which I introduce the PW mini project. So be on the lookout for that.